There are 7.5 billion people on our planet today, and each and every single one of us has a unique set of chromosomes that can determine our traits. But to better understand why, let's travel back to 1856. This is Gregor Mendel, also known as the father of genetics. Now, while he was planting peas in his backyard, he noticed that some offsprings were not the same color as their parents. This must have meant that the genes were randomly passed down from the parents, causing this genetic variation. But this variation that lies in a discrepancy between the base pairs of a gene, also known as a single nucleotide polymorphism, can tell us a bigger story than just a certain trait. This urges me to question, how can we use Mendel's discovery to solve certain epidemiological diseases today? The answer lies in figuring out a way we can identify factors that could increase or decrease the risk of having a particular disease. Let's take, for example, vitamin D, a risk factor, also known as an exposure, and its effect on the risk of cancer, an outcome. We could identify a statistically significant association between the vitamin D levels in your body and the risk of cancer. But a major limitation of this association method is the consideration of confounding variables, or external influences. In this case, a confounder could be the amount of exercise someone does, their exposure to sunlight, or their diet, which all directly affect vitamin D levels. This prevents us from finding a causal relationship between the exposure and the outcome. So we really don't know if the external influences cause the outcome or the exposure itself, which could be pretty misleading while trying to find a proper treatment. So how can we really find this causal relationship? That's where Mendelian randomization comes into play. Now, Mendelian randomization uses Mendel's centuries-old discovery of genetic variation. Some people are genetically predisposed to have higher or lower levels of vitamin D, and the likeliness of having that particular gene variant is simply random, without having any dependence on a person's exercise, exposure to sunlight, or their diet. Therefore, a specific gene variant can lead to a lower level of vitamin D, causing a higher level of cancer, and vice versa. Furthermore, the risk of any external factors in our study is completely eliminated, because genes are something that will never change, which gives us a straight path from our exposure to our outcome. And that is the true beauty and genius behind Mendelian randomization. But Mendelian randomization has a wider impact than just cancer. Take the most recent example, COVID-19. Finding a known exposure such as fatigue or shortness of breath and assessing its correlation with a particular gene variant can far more accurately identify people with the disease. Mendelian randomization is a step into the future for epidemiology. So the question now remains, to what extent can we use this incredible technique to protect the billions of people in our world?